In this chapter, I will prepare the collision geometry. So as you can see, we have the body here, and I added the collision group. You can call it whatever you like. I selected the body area where I want to fix the intersection in the body, and I will use this group in the triangle and the subs I will use to fix the intersection. Okay, in this method, I will have a VDB object, a VDB from polygons, and we use this VDB to calculate the intersection and fix it with it. So if we have VDB from polygons, and I will increase the resolution a little bit, like this is good. Fill interior, and this is good. So I will add attribute triangle, and the VDB will be in the second input, and we will sample this volume, and we will use it to push the normal in the intersecting area. I will add like a soft peak. Let's go to frame, for example, 1014. As you can see, we have like an intersection here, and if we push, subtract, it will be avoiding each other, but this effect on everywhere. With this, we will do only on intersecting area like this. This area will be affected, and these, like this area, will not be affected. So I will rename this triangle as DF push. First, I will sample the VDB volume. I will call it VDB volume sample. I will sample the second input, which is number 1. The primitive is the only primitive we have, which is surface number 0. We are gonna sample the position. Now I will add if VDB smaller than, I will add like a float attribute, call it offset. At B, I will subtract the position with the normal, multiply by also a float attribute. Let's call it push. So now I will, 1 second. Let's try to push 0.01. As you can see, now we are pushing only on this intersecting area, and it's going too much on concave area. So we have the offset attribute like minus 0.001, or you can go up 0.002, and now it's only on intersecting area like this, and we don't need to affect the face and the hands, so this will be only on the collision group, which is we did at the beginning here. Now I would like to do a delta mesh to smooth this geometry. Now it's much better, but as you can see, yeah, let's increase this a little bit. Now this is good for simulation. We have a gap for the cloth pieces to go inside, but this delta mesh is everywhere, and we don't need this. We are gonna create attribute based on the only this affected area, and we apply the delta mesh only on this area. Okay, so I will add another attribute triangle, and this is the first input, and this is the second input, which is the original position. Okay, I will call this stress B. I will add a vector called old B. We sample the second input position, which we are using ob input. One underscore P. We are sampling the position. If we are apply this to the position, it should use the second input position. Let's try it. Okay. Alright, so now we are gonna use this old B to calculate the distance between the old position and the new position, and we have a distance. This is we will use it like as a attribute to drive the delta mesh. Okay, so I will add a new attribute of add stress. I'll call stress underscore P. Distance between the original position and the old position. Now we have attribute. If we see the attribute, we can see anything. If we go and remap it, we can see, because the push amount is 0.01 or 0.015. So if we go 15, we have all the range here, but we have to remap this directly inside this attribute triangle. So we don't we like to have it from 0 to 1. So revert it back to 1, and I will add a fit and fit this from 0 to 1, from 0 to 0.01. I will add like a float attribute and link it to this attribute, for example, or manually change it. But yeah, 0 and a float attribute called also push, so we can match it. Okay, and now from 0 to 1, close it, As you can see now, we have attribute from 0 to 1, but we have to make this, like for example, link it to this one. And we always have the right amount. Okay. Now I will use this to drive the delta mesh. Stress underscore B bigger than 0.01, for example. And as you can see now, it's smoothing in this area. But this is not enough. We have to blur the attribute, so we have it surrounding this area. Okay, let's 1 second. Keep this the attribute to blur. And we like to use a stress B and take pin border point and do, for example, 10 iterations. And now, as you can see, it's affecting only this area. And let's play with the iteration. Okay, this is too much, 10 iteration for the delta max. Let's go 5. And for the blur, if we decrease it, we have less. If we increase it, we have more. So based on your need, you can increase it or decrease it. For example, 10 is good, but the delta mesh is like having like a hard edge here. I will add another delta mesh, and this will be referenced with the rest pose. I will add a time shift and F start. So this is the reference geometry in the second input. Now we have a smooth geometry across everywhere. We reduce the effect because we don't like to affect unwanted area or because like this. We try to make sure we maintain the original shape, but we are gonna reduce the step size also. So we have like this is a soft on top of the previous one, a soft delta mesh. And I think that's it for the fixing the collision geometry. If we compare this one with this one, it's now much better in terms of intersection. And this way we have like we can have a better simulation, avoiding these bad geometry in the simulation. This will cause a lot of intersection and will break the simulation sometime. Okay, so you can pipe this directly into the solver and you will have a better result. That's clean. And I like to talk also about sometime we have like a bad geometry and we like to remesh it. For example, I take this, the same geometry, and I did something on purpose like this, and I cut the head from the body. Like sometimes we have a geometry like this, and when you do simulation, the cloth go inside and go outside, go inside, go outside. This causes you an issue with the collision in the solver. So in these cases, what we do, we are make a VDB from polygons. So we recalculate everything on the first frame and convert it, remesh it like this, and we have one uniform object now. Sometimes you have like multiple pieces, and these pieces go with multiple faces, and this causes you an issue. So this proxy method is useful in some cases. So you can decide, and if you have a clean geometry like this one, and this will be working for you in the solver, you can go directly with it. But sometimes you have to remesh it. Something like this will be better for the simulation, and we will have like a uniform everywhere, uniform geometry. So this will help in the collision also. But this will be much slower because the amount of geometry it will be calculated. I think this is too much for collision. I reduce it with a poly reduce. This is also I equalize the length 0.1. So we have like a equalize the length. But for collision, it's not an big issue if it's not equalized. But this is much better when you deform with the original. Okay, so after that we point deform the original with the original animation, and let's go to frame, for example, 14. As you can see now, we have the intersection here. If we take this and do the same thing, because we have a new geometry, we have to reselect the body area. So let's select it quickly, like this. Okay. So now, if we like a VDB from Polygon and SDF push based on the collision group, and we calculate the stress B, which is, let's see, if we go back to this frame, see, we have also good looking fix here. If we compare it to this one, it's also good. So sometimes using this geometry is much better for the simulation. You can decide which one you like to go, but for now we are going with this one. And if we see the geometry not giving us a good result, we can switch to the proxy one. But I will show you first this one, and if needed, we can go to the proxy one. Also, there's another method of fixing intersection with a solver. This is more accurate, but this way is a bit slower. As you can see, I prepared this node to show you what I did here. I take the same animation, I make a cloth. This is based on the collision because we are using the collision group. Okay, I make a cloth node, normal cloth node, but in this one, I make sure we have a bigger thickness for the. It's because the default is 0.01, 0.025. This is not enough to have a gap between the two layers or the two sides. So I go up like 1.3, and when these two pieces interacting with each other, it tried to have like this amount of gap from each side. So we have a good gap here. And we bin everything, not collision group, to animation. This is a parent bin, so it's not as soft. So this will be always the same position as animation. And now we have a bin to target from constraint, and this one is a soft constraint. I increase the stress stiffness as much like this, but this area will be like a soft. So the solver will decide if like it's intersecting like this. We'll try to keep these pieces from each out from each other. So I here kill the gravity. We don't need any gravity, and I add like a three substeps and no other thing. Like this only changes. Kill the gravity and add three substeps, and I did the cache, and you can see this is the result from the cache directly. So sometime using this method is much more accurate, much more better for you. It depends on your geometry, but this can cause you an issue. So, for example, this area is pushed also inside, and this will not be matching the geometry, the original like geometry. Sometime, if we do this frame, yeah, it's a little bit pushed because the tension, but you can make the pin also another pin with a permanent pin here on the knee area, like the corners, the area you want to keep the same position always, never change their position, and this will be giving you the right result. But this method is good for some cases, but it's slower, especially for pipeline or for like doing a lot of shots and running into the farm. You are trying to do caches or simulation at as much as possible. So you have two methods to fix the intersection in the geometry. One is with a VDB and SOPs, and the second one with a simulation. So you can decide. I think that's it for this chapter. See you in the next one.